Assalamu alaikum, kids. Inshallah, in this video, we will talk about objects that are falling. So, in physics, we call that motion under gravity or free fall. We study free fall in two different conditions. One, objects in free fall in vacuum. Two, objects in free fall in air. Now, the way objects which free fall in vacuum differ from objects that free fall in air is that objects that free fall in vacuum do not experience any air resistance. So, when weight is the only force acting on an object, it's considered to be in free fall. If an object is held in an evacuated chamber, so a chamber in which vacuum has been created, and if that object is let go of, it will become free fall due to its weight. Weight is essentially the force of gravity on an object and can be figured out using the formula W is equals to mg. The formula essentially tells us that weight is directly proportional to the mass of an object. It's important to remember that the balances that we use to measure mass actually measure weight, and they are calibrated to give you the mass according to that weight. The weight of an object stays relatively constant independent of the height above the surface of the earth. Like, let's say, for example, if an object is on the surface of the earth, or if the same object is on an airplane thousands of meters above the earth, we will assume or we will consider that the weight of the object is going to be approximately the same, even though practically it isn't. But we in our course will consider that an object on the surface of the earth and an object flying in a plane thousands of meters above the surface of the earth will experience the exact same gravitational force and will have the exact same weight. Objects in free fall without air resistance will experience the full acceleration due to gravity of Earth, which is 10 meters per second squared. These objects will keep on accelerating till they hit the ground. Let's say, for example, you have a feather and a hammer. In vacuum, where there is no air resistance, the hammer and the feather will experience the same acceleration, and if let go from the same height, they will reach the ground at exactly the same time. Let's elaborate on the behavior of the hammer and the feather in absence of air resistance. Now, of course, the gravity does not exert the same amount of force on the hammer and the feather. The hammer, being more massive, requires a much larger force to accelerate it at 10 meters per second squared. The feather, being much lighter, requires a much smaller force to accelerate it at 10 meters per second squared. Remember, force is equals to mass times acceleration, where acceleration, of course, in vacuum will be 10 meters per second squared. That does not change, but the force applied is directly proportional to the mass. So the greater the mass, the larger the force of gravity applied on an object. Hence, we can conclude that the gravitational force on the hammer is much higher than the gravitational force on the feather. And you need to remember that more mass requires a greater force to accelerate it, like we discussed using the formula force is equals to mass times acceleration. On the other hand, objects will experience errors. On the other hand, objects in free fall will experience air resistance in the presence of atmosphere. Air resistance will oppose the motion of the falling object, hence it will be in the upwards direction. So let's take an example of a hammer and a feather. The feather experiences higher air resistance due to its large surface area, but it is lightweight due to its small mass. The hammer will experience a much lower air resistance due to its compact shape, but it is very heavyweight due to its large mass. If a hammer and a feather are allowed to free fall from the same height in presence of air resistance, the hammer will reach the ground earlier than the feather. It is important to note that air resistance does not exceed the weight of an object unless the object changes shape. Example, opening a parachute.